Okay, welcome back guys to the second part of the tutorial for OpenGL beginners. And what we're going to do in this video is we're going to render a white triangle to the screen, and that's about it. And it takes a bit of work because you got to get an understanding of what vertices are and how they're rendered to the screen and such. But we'll get along and we will eventually get that triangle printed on the screen. So the first thing that we're going to want to do is we're going to initialize glue. Now what glue is, which I mentioned before, is it's a GL extension wrangler. And this means what it does is it kind of assists you in enabling and disabling certain OpenGL features and stuff like that, and it's always a recommended sort of thing to have if you're ever using OpenGL C++. So what we're going to do is we're going to import it, include it, shall I say, and you should always include it above GLFW because I don't know why, but it's very picky about the order that you do this. So what we're going to do is we're going to do glue, we're going to do GL/glue. And then just after you've created the window and you've set the context, glue must be called after you've set the context because that's how it works. So what we're going to do is we're going to do if glue init, and when you call glue init, what it returns is a value, and we're going to check if that is not equal to glue_OK. And what this means is basically if it's anything other than OK, so if the init method returns anything other than OK, that means there must have been an error involved in this. So what we're going to do is we're going to, you guessed it, fprintf std error, standard error, glue failed to initialize. Oops, sorry, I'll do it my own spelling there. Printf. Then we want to terminate the glfu. Just for good practice, to be honest. Then we're going to return an error code. And before we actually initialize glue, I forgot to do one thing, and that's we're going to type glue experimental, and we're going to set that to true. That just enables glue for the newer version of OpenGL basically, and make sure that you can actually run it in your program. And at this point, what we're going to do, I think we shall try and run this program now. And if it all compiles correctly, then it's all fine. There we go, we got no errors, it's working perfectly. And after we created glue, we're going to start getting into the nitty-gritty bits. And this is where you might need a older understanding, you might need your own sort of understanding what vertices are, what they do, but I'm going to try and explain as I go along. And what we're going to do is, the first thing is we're going to want to create something called a vertex array object. You're not going to use this at the moment, but it's something you should really have in your GL. Well, you have to really have in your GL programs. So what we're going to do is we're going to type. Well, we're going to get a GLuint. This value is what OpenGL kind of uses for all its IDs for anything. So I'm going to call this the VAOID, and that's what I'm going to do. So then you're going to type GL bind vertex array. And then type VAO. What this function does is this basically tells OpenGL that we are currently going to use this. We are going to use this kind of vertex array. But obviously before you tell OpenGL to use that array, you've got to create that array. So what we're going to do is we're going to call GL gen vertex buffer vertex array. Sorry, it's going to ask us the amounts that we want to create, and then it's going to ask us, well, what array would you like to create? What's the ID of this array you'd like us to create? And we're going to pass in a reference of VAO ID. Now this might look a bit unfamiliar, but what we're asking it to do is we're asking a GL to generate vertex arrays, which we don't need to get into at the moment. You just need to know that this kind of has to exist for the upcoming example to work. And you're asking it to create one array, and the reason we're sending in a reference to our vertex array object ID is because behind the scenes OpenGL gives us the ID back. So it's going to edit the ID, and then from then on we're going to have a completely different ID. So if I do this, for example, and then I fprintf, I'm not entirely sure if I can actually do this, but I'll try. Oh, poop, my bad. std out, and we want a d for integer or whatever. I think that should work, I hope. Let's try it, see what happens. Oh, we didn't get any output then. Oh yeah, we did, we got 1, okay. Well, basically, as you can see, we set the value to 6, and then we asked OpenGL to generate the vertex array for us, and what it's gone and done is it's changed the value of our ID. So we don't actually get to set that. What we do is we tell OpenGL to generate it for us and then give us back the ID without actually setting the ID ourselves. And then we bind this vertex array by basically all that's doing is saying, OpenGL, listen, this is a current array I want you to do for any actions we're going to do after this. So it's going to use that object array sort of thing. And now after this, I'll put a comment in there actually, and I'm going to say generate vertex array object. And if you don't know what one of those is, you should go online and have a browse on Google and learn for yourself a little bit. And the next thing I'm going to do is I'm actually going to create a triangle out of vertices. And if you don't know what vertices are, they are points in space essentially, and typically come in X, Y, Z value in the 3D world. And I'm going to try and talk you through this while I do it. So we're going to make a static const GL float, and then we're going to call this, I don't know, what should we call it? Verts equals array equals X, comma, Y, comma, Z. Okay, so let's just put in a value in there to shut it up. Okay, so what we're going to do is we're going to create an array of float values, and what floats are is they are values obviously that have a floating point number after them, so like 1.5 or 2.79 or any of those sort of numbers. And we're going to give vertices, basically when you look at your screen, like the screen you're viewing now, the top left is known as 0, 1, the top right is known as coordinates 1, 1, the bottom right is known as coordinates 1, 0, and the bottom left is known as 0, 0. And the coordinates are a bit strange if you've been working in like a 2D Cartesian coordinate system, but basically you start from the bottom left in these coordinates and then you go up and right for increasing the value to 1. So what we're going to do is we're going to create this triangle out of we're going to use 3 vertices, but each vertex, shall I say, needs 3 values. It needs an X, Y, and Z value. So what we're going to do is we're going to start from the bottom left, we're going to go to the bottom right, then we're going to go to the middle at the top, and that should kind of sort it all out for us. Oh no, I lied actually. The center of the screen is 0, 0. Bottom left would be -1, -1, and the top right would be 1, 1. Sorry about that. Anyway, so we're going to get started. We're going to start at the bottom left, so that's -1.0. Oops, got caps lock on. Oh god, why have I got caps lock on? Then we're going to start at -0f. And for these examples, it's going to do 0.0f in the Z, because we're not actually going to be using the Z to draw a triangle on the screen, but we're just using it to, you know, set an example and prove that we are working kind of in a 3D world here. So then the second one's going to be the bottom right, which means we're going to do 1.0, sorry. Then we're going to have -1.0f for the Y, 0.0f for that. And then for the last vertices, which is going to be up here in the middle, right at the top middle of the screen, the X index will actually be 0. Oh, sorry, 0.0 f, and then the Y is going to be 1.0 f, and the Z is still going to be 0.0 f. So I'm going to try and demonstrate this now. Okay, so I'm going to open good old trusty Paint here. Now, if this was a screen that we're looking at, right in the center here we would have 0, 0, and then right at the bottom left we would have -1, -1, and then at the bottom right we would have 1, -1, top left would be -1, 1, and this would be 1, 1. So what we're doing here essentially when we're setting these is the first vertex is going to have the X -1, which is over this side of the screen, and its Y is going to be -1, which means it's this coordinate here. We put a circle here, that's going to be one vertex. Another vertex is going to have a 1 on the x, which is all the way over this side, minus 1 for the y, which is at the bottom, and it's going to have 1 minus 1, which is there, so that's another vertex. And you should be able to figure this out by yourself. The next one's going to be at the top, so it should be 0 on the x and 1 on the y. So you got 0 on the x here, right in the middle, and 1 on the y is up top. You can do that. And then obviously if we draw this out, and then draw up there and then back down here, we've got our triangle, which is what we're going to be drawing on the screen. So I hope that's given a little idea of how vertices are going to be implemented in this example. So after we've created this, what we want to do is we want to create a vertex buffer object. So let's put a comment in here. And generate VBO. We need an ID again. For most buffers and shaders and whatever you're going to use, normally you're going to be creating IDs. Yes, IDs. So you're going to have to get used to typing these out. So we're going to set a vertex buffer ID up, and the first thing you want to do, as usual, is you're going to want to generate the buffer. So gen buffers, we want one buffer, and well, we want this one here. We want the vertex buffer ID. So it's going to create one buffer, and it's going to assign VBO ID, the ID of the buffer it just created. And then after we've done that, we've gen the buffer. Then we need to GL bind buffer. The target is GL_array, and then we're asking for the VBO ID. Okay, what this function here, GL bind buffer, does is the same. It kind of does the same thing as GL bind vertex array. It kind of tells OpenGL that this is a current buffer we are working with, and whatever GL calls we call in the future to modify any buffers, this will be the buffer that gets modified. So for example, if I called some code to modify the buffer, so like if I did like modify buffer, and let's say that did some code that modified the VBO buffer that we just created. If I called GL bind buffer, and then I called another sort of ID, it would say, alright, ignore the last buffer GL, this is the current buffer we're working with, and then all I'd have to do is kind of call modify buffer again, and it would kind of just, it's kind of a complicated concept, and I guess the reason why OpenGL has done this is because originally it's a C sort of library. But anyway, it's kind of hard to get your head around that, and you just have to kind of use it. And obviously it's an array buffer, because we have an array up here. We've got a vertex, it's an array of vertices. That's why we call it a GLArrayBuffer. And then after we bound the buffer and we've generated the buffers, we're going to have to fill that buffer with data. And the GL has a function for this called GLBufferData. There we go. Okay, and what we're going to do is we are going to fill the VBO ID. That's going to be the buffer we're filling. The size will be the size of verts, because it asks you in advance what the size will be. The data we're actually using is obviously going to be verts, and then we want GL_static draw, which is kind of the default you'll be using for drawing things, drawing any entities on the screen. Okay, so that's all good, and what that's done, that has now created the VBO for us, and now we can move on to the actual drawing of the vertices. Now what we're going to do is, in here, just to play it safe, you don't have to do this, but I'm going to copy this line of code here, and then I'm going to paste it back in here, because what this ensures is because what this says, as I said before, is it says ERGL, we're using this buffer which is filled with our vertices which we set up top, and that's what the data is of this buffer, and that's what we're going to be manipulating and using. And just above this, I'm going to do GL enable vertex array attrib array, I think, can't remember, attrib array. There you go. And then we're just going to use any number. You can use any number there, as long as it's kind of below a certain value, which you can look up online. And then we're going to call GL Vertex Attrib Pointer. Pointer. Oh, and what it's going to ask for is it's going to ask which vertex attribute array would you like to use. So because we've just enabled the number 0, we're going to use 0. And the size of this is going to be 3 because we have an x, y, z value, and that's what we've kind of assigned in our array of vertices in our VBOID buffer. That's what we've that's the amount of values we have for each vertice. And then you have to say the type, which is a GL float. That's what we filled it with. We have normalized it, but we're going to say we haven't in case in case I don't know how to say this. In case you use any other values, like say you used 100 or something. So I'm going to put GL false for here. That's poorly explained, I'm sorry, but and for the last one, it's just common practice to use a void pointer, then put 0 because that's what it asks for. Otherwise, you'll probably be getting errors everywhere. And and just before the end of the loop, just before basically the end of the loop, what we're going to do is we're going to disable array. Brilliant. Then we're going to disable that. Okay, so after this we want to draw GL draw array. We want to draw triangles, so GL triangles. First will be 0, and we've got 3 for the count. Okay, it's good. That means it wants to draw triangles starting from 0 in our buffer, and then it's going to draw 3 vertices, which is bam, bam, bam. Oh, crud. Bam, bam, and bam. If we run this, that could work. Hopefully it should, without any error. Oh, no, it didn't. Oh, that's strange. Oh. Okay. Oh. Hey guys, I'm back, and the problem was, it was a very tiny problem, a very, very tiny problem in fact, and all it was inside this GLBuffer data function that we had, where you fill the data of the current buffer, we used an ID, which is silly because we've already told GL which buffer we're going to be using, so why would it need the ID? What it really needs is to know what type of buffer it's filling, which is a GLArray_buffer. That's all it asks for. It says, hey, can you at least tell me what kind of buffer I'm going to be filling here, and what's the size of it, and what is the actual data? And then you say, well, how am I going to draw it? And basically, after I've done this, I'm going to run it. I'm going to click yes, please. And there we go. We got our triangle. Yeah. So that's our triangle. That's our triangle. Over 70 lines of code to draw a triangle. It's a proper problem, that is. But it's good code. It teaches you the basics. I'll go through this bottom bit just once more, just to make sure you're aware of it, and then we'll probably move on. So at the very top, what we do is we generate the Vertex Buffer object, and we create it, assign it an ID. Then we bind the buffer and say, hey GL, this is our current buffer we want to put data into and use. And then we say GL buffer data, and we say, listen, we're going to fill it with this type of data. This is the size of the data that's going to be filling it. This is the actual data that's going to be filling it, and this is going to be the way it's going to be drawn to the screen when we do draw it. And then during the while loop, this means every single frame, we're going to enable the vertex attribute array 0, and basically this means this is used for shaders primarily. But if you like, some people may not actually see a white triangle on the screen. If you don't worry. This will all be. You might just need to enable shaders for your program to actually work. But some people are lucky, like myself, and don't need to have shaders. And basically, this is primarily used with shaders, which we'll explain in the next tutorial. We enable the vertex attribute arrays, and then we disable them after we've drawn. And then each loop it goes through the same thing again. We bind the buffer. We don't have to do this in this small example. So if I go like this, and then it should hopefully work the same way. As you can see there, we don't have to do it. But the reason I did it is because before you use a certain buffer, you should always bind that buffer to the current GL. And you should say, hey GL, look, before you do anything with this vertex attribute pointer, please use this buffer. So that's what we wanted to do. And then after that, what we did is this complicated function name, isn't that complicated. You just have to remember it and think, well, it's a pointer used inside the shader and all this sort of stuff, which I'll explain in the next tutorial. And then you tell it what the ID is. You tell it how many sort of elements does it have, how many elements does it use in this certain vertex attribute when it's free, because we've got an x, y, and z. Those x, y, and z values are floats, GL underscore floats. We have not normalized values, in the sense of this example at least. Actually, I'm very curious to see what happens if we put true here. I'm assuming not much would happen. Oh, look, nothing at all. Oh, well, let's leave this false for now. Shride. Shride is basically how many it misses out after each one. So if I put the shride as 2, what it would do is it would read the first 3, and then it would miss out 2, then it would do the next 3, then it would miss out 2. So for example, it would check those 3, and then it would miss those 2 out, then it would miss these 2 out, then it would go to that one, it would check these 3, then it would miss that one out, and yeah. That's basically what shride means. It means how many would you like to miss out each time. And offset is pretty obvious, it's how many it'll miss from the beginning. So like if I put offset as 2, it'd start here, and so on and so on. Well, I think that's all we can do. In GL draw arrays, you say what do you want to draw. Like there's a thing called a GL triangle strip, and there's many ways to draw things, but the standard way of drawing things is typically a GL triangles, and I believe, if I am correct, there are GL quads as well, which is a common way of drawing vertices to the screen. We start at 0 and we draw 3 vertices, so that's why we put 3 there. Then we disable it, then we swap the buffers, and then it starts drawing to the back buffer again, then that back buffer becomes a front buffer, then it goes to the back buffer again, and that's what the loop does. And that's essentially what this whole tutorial has been about, is drawing this and trying to get you a basic idea of what's actually happening. So I hope it's helped. I'm sorry for the really lengthy tutorial, and if you liked it you can send me a comment, tell me how I've done, blah blah blah, and I hope to see you in part 3. Goodbye.